Welcome everyone to the fifth session of the second module of the comprehensive neuroanatomy educational course organized by the Yemeni Neurosurgical Society in collaboration with the World Federation of Neurosurgery, Young Neurosurgery Forum, and Neurosurgery Coach, along with the Pakistani Society of Neurosurgeons and Neurosurgical TV. In today's session, we will have two topics, basic anatomy and white matter tracts. And Dr. Abuzar Gungur, Professor of Neurosurgery, who will be the moderator of today's session. Dr. Abuzar, welcome.
Welcome all participants. Thanks, Ahmet, to organize these meetings, and it's an honor to introduce to Dr. Barış Küçükyürük from Turkey, Cerrahpaşa University. Also, he's a former fellow of Professor Loton, and he is still has a laboratory in their university and still studies about brain anatomy. And also he is expert in basal ganglia anatomy. Today he will present the microsurgical anatomy of the basal ganglia. Then we will have Abida. He will join soon. Professor Barış, please, you can start.
Okay, thank you. I just couldn't find a way of having a pointer, even my mouse pointer, but still I will try. So I will be talking about the microsurgical of the anatomy of the basal ganglia, but before we start, we should speak on the terms about this topic, because when you're reading articles or hearing presentation like this, you will hear a couple of terms like basal ganglia, central core, or even the striatum. Basically, they all involve the same thing, but also from a functional point of view and an anatomical point of view, they are very different. The basal ganglia, my topic today, includes these nuclei, as we know them, the caudat nucleus, lentiform nucleus, which involves the putamen and the globus pallidus, nucleus accumbens, thalamus, subthalamic nucleus, and substantia nigra. So basically, I will be talking about these nuclei and their anatomical relationship. I won't be speaking too much on their functional relationships because it's another topic. It involves movement disorders, even some neuroscientific stuff. So basically, I will be speaking on the anatomical relationship. But we also, I also would like to express that the term central core is more an anatomical term, involves the basal ganglia, but between the insula and the lateral ventricle. So the mesencephalic structures such as the subthalamic nucleus and substantia nigra are arguably not involved into the central core. Also, you'll be hearing a term called as striatum. Striatum also involves or includes the anatomical structures of ventral striatum, the striatum, but it doesn't include the thalamus, because the term striatum is a more functional term. It basically involves how the information from the neocortex comes to the basal ganglia is structured and then presented as an output information to the thalamus. So striatum doesn't involve thalamus, the central core doesn't involve the mesencephalic structures, but the basal ganglia is a more arguably term. So now, somehow I don't have any pointer to show, and I don't know how to put one. Let me try again once more. I think you don't see any pointer on the screen.
No,
Yes, we don't.
we couldn't see.
You can exit screen sharing and share again. See if that will work.
The problem is all my, I don't see even a mouse on my computer, so I don't see one. I think now you see one.
Yes, we see one, but it's not in full screen mode.
Okay, but I think it's better we go this way because it's still okay. The sizes of this pictures will be the same. So let me go like this. It will be better, I guess.
Okay.
So, so now we are looking to the left central core. As I said, the term central core involves the structures between this left insular cortex until to the ventricle. So in between them, there is basal ganglia and also some association fibers. So let's go into more detail. So the central core includes the insular cortex. From lateral to medial, there is extreme capsule, there is claustrum, this small gray island, then external capsule, and then comes the basal ganglia, the lentiform nucleus, internal capsule, the caudate nucleus, where we see just the head of the caudate nucleus, forming the lateral wall of the frontal, forming the lateral wall of the body of the lateral ventricle. Again, the central core, except the lobes of, the frontal lobe, temporal lobe, parietal lobe, except this, it includes both cortical structures, subcortical structures, and also some of the basal ganglia. Now we see just the basal, again, the central core. Now this is a coronal cut. These are the lateral ventricle, septum. This is the right insular cortex, left insular cortex. Here we see the brainstem. These are the temporal horn. We are looking from anterior. Now we see all the basal ganglia and all the striatum and all the central core. Let me go a little bit into detail. So again, let's first speak about the central core. This is the insular cortex. This gray island here is the claustrum. Lateral to it, there is extreme capsule, and medial to it, there is external capsule. And then comes the basal ganglia, the lentiform nucleus, including the putamen and globus pallidus. So the lentiform nucleus is formed by the putamen laterally and globus pallidus medially. And then there comes the internal capsule. And more medially, there is the caudate nucleus, then the thalamus, and beneath the thalamus, there is the subthalamic nucleus, and then the substantia nigra. So again, the central core includes the structures between the insula and the lateral ventricle, not the subthalamic nucleus and the substantia nigra, which are more brainstem structures. But the basal ganglia includes these both structures. The striatum is a little bit more complex understanding. Allow me go a little bit more into detail. So basically, the striatum is structures which get the information from the neocortex. So the information first comes to caudate nucleus and it is processed there. Then it goes to the globus pallidus and then pushed to the thalamus. So the striatum involves the caudate nucleus and the lentiform nucleus. So let's see the structures from lateral to medial. Now we see the insula insula has 3 short gyri, the anterior, the medial, and the posterior short gyres, and 2 long gyri, the anterior and the posterior long gyri. In between them, there is the central sulcus of the insula, which sulcus on the surface of the brain between the precentral and postcentral gyrus. Then when we remove this insular cortex, the first thing we see larger dorsal claustrum and the smaller ventral claustrum, which we'll see a little bit in the detail a little bit later. But the first layer after the insular cortex is the has small association fibers between the gyri of the insula and also the dorsal claustrum. When we go a little bit more deeper and when we remove the dorsal of the extreme capsule, now we begin to see small islands of the gray cortical matter, which is the ventral claustrum. The dorsal claustrum here is removed to expose the external capsule, which is the beneath structure to the claustrum. And here are partially opened the an external capsule to expose the lentiform nucleus, in more detail the putamen. Let's go once more. And here then we see this is the Yemeni insula here. In the ventral part of the external capsule, there is 2 association fibers. The first one is the uncinate fascicule. The dorsal one is the inferior occipitofrontal fascicule. And in between their fibers, there are small islands of gray matter, which is the ventral claustrum. Dorsally here, we already removed the dorsal claustrum to expose the external capsule fibers, external from all around the neocortex to the dorsal claustrum. And when we begin to trim or cut the external capsule fibers, then we begin to see the basal ganglia, the most lateral one, the lentiform nucleus, more detail, the putamen. So just let me go a little bit off from the topic to show something like this. This is how the association fibers of the brain works. This article is not a medical article, actually. This basically speaks about how the information is carried even from the smallest cell to the larger galaxies even. Basically, it says the best way to carry an information is forming short fibers or short paths between the hubs. But this is a very slow way of carrying the information, because from here to here, you need to carry very slowly from each hub to each hub. And you will then also use too much energy. But this random network on the most right one carries in a faster manner, let me say, but again uses too much energy because each hub needs to be connected with each other. So how our brain works is called as the small world network, which means there are hubs and they are connecting with each other, but some specific hubs are connected with longer fibers on the other side of the brain. Let's see this one. As I say, these are specialized regions. They are connected with U fibers, but they're also connected with longer fibers. So this uncinate fasciculus and inferior occipitofrontal fasciculus are association fibers, just like the U fibers of the cortex connecting adjacent gyri, and U fibers are too many, but we also have association fibers like superior longitudinal fascicule, inferior occipitofrontal fascicule, or uncinate fascicule connecting and not adjacent, contrary, far cortical areas from each other, but from here to here, it's the best way to carry the information. That's how our association fibers in the brain is developed, let me say. So here we see, let's go back to the topic. So all the external capsule fibers are removed to expose the lentiform nucleus, the putamen here, and more medially, we begin to see the internal capsule fibers. Let's go and see a little bit more detail. So the dorsal part is removed. We just see the ventral part. So these are ventral external capsule fibers, which host the uncinate fascicule fibers and inferior occipitofrontal fascicule fibers. And in between those fibers, there are small islands of gray matter, which are the ventral claustrum. As I say, the dorsal claustrum and dorsal external capsule fibers are removed to expose the putamen here. And when we remove all of it, then we begin to see the internal capsule fibers. On the posteriorly, it carries the primary motor fibers. Anteriorly, it will be something else, which we'll be speaking later. So putamen and also the globus pallidus is removed, and ventrally there is a structure called anterior commissure. I won't be going into much detail with the anterior commissure because it doesn't have anything to do with the basal ganglia. Just let me show in another example. So this is the anterior commissure, this is the putamen, this is the globus pallidus, and anterior commissure basically connects each hemisphere, the temporal lobe and occipital lobe, which are not so well connected through the corpus callosum. So the anterior commissure is actually a sideway for the corpus callosum. Corpus callosum connects the frontal lobes, parietal lobes, and occipital lobes, but lateral wall anterior surface of the occipital lobe is not so well connected through the corpus callosum. So the anterior commissure does that work. Anterior commissure is the superior limit of the subthalamic nucleus, which is a basal ganglia, which we'll be seeing further. So now we'll be discussing the structures from anterior to posterior in a right hemisphere. Again, we see here the insula. When we begin to remove the insula, here I removed the short gyri of claustrum and the external capsule fibers. As I said, external capsule to the dorsal claustrum. Its anterior part is partially removed here to expose the putamen and then the internal capsule fibers. And ventrally, again, we have the ventral external capsule fibers, which host the inferior occipitofrontal fascicule and the uncinate fasciculus. When we remove all of it, then we begin to see here the putamen. So again, this is the right hemisphere. And then I begin to turn the hemisphere a little bit. Now we see from the anterolateral and then from completely from anterior. Now we'll begin to go from anterior to white matter structures. As I said, the striatum is formed by the nucleus and the lentiform nucleus. Here laterally we see the putamen, and normally on the axial scan of an MRI, we don't see this connection, but actually they are gray matter structure, which is most anteriorly called as the substantia innominata. This is a very vague term. Let me say substantia innominata. Its borders are not well defined. I can just say connecting the caudate nucleus head and the putamen here forms the most anterior border of the substantia innominata. Again, this is a right hemisphere. Here we see the roof of the lateral ventricle, which is formed by the corpus callosum. The white matter structure between the head of the caudate nucleus and the putamen is the anterior limb of the internal capsule. Let's go a little bit more posteriorly. So the anterior limb of the internal capsule is removed. The head of the caudate nucleus becomes the body of the, you'll differ the change of color here. This is the lentiform nucleus here, but laterally it's putamen and medially it's globus pallidus. So the gray matter structures connecting the caudate nucleus and the lentiform nucleus here is called as the nucleus accumbens here. Maybe it will become more clear with these two pictures put side by side. This is again a right hemisphere, the lateral ventricle here. The roof is formed by the corpus callosum. This is the internal capsule going into the basal ganglia. This is more posterior to the anterior limb, but still we are anterior to the foramen of Monro, let me express. So this is the posterior part of the head of the caudate nucleus, which will begin to be the body of the caudate nucleus. So this is the lentiform nucleus here. The laterally it's putamen and medially it's globus pallidus. This is the anterior commissure we already talked about, and beneath the anterior commissure, the structure is called as the nucleus accumbens. Let's go a little bit more posteriorly. We begin to see the foramen of Monro. After the foramen of Monro, the head of the caudate nucleus will be the body of the caudate nucleus, the internal capsule, the lentiform nucleus, the anterior commissure, and we go more posteriorly. This is the body of the caudate nucleus, which forms the lateral wall of the lateral ventricle, but still we are anterior to the thalamus. Of Monro, the caudate nucleus becomes the body of the caudate nucleus. Both of these structures there is the posterior limb of the internal capsule, which carries the primary motor fibers. The globus pallidus begins to diminish, and we see the posterior part of the putamen here, basal ganglia. But to have a better understanding, particularly the caudate nucleus, I would like to show these pictures of the right hemisphere from this time from medial to lateral. So the cortex is removed. This is the corpus callosum, the fibers of the corpus callosum, as I said, connecting the frontal lobe, parietal lobe, and through the splenium, the occipital lobe. The septum is removed, and partially I will be removing the anterior part of the corpus callosum to have a view of the caudate nucleus. So the anterior to the foramen of Monro, which is basically located here, the caudate nucleus is the head of the caudate nucleus. forming the lateral wall of the frontal horn of the ventricle, and more posteriorly, it's the body of the corpus callosum, which forms the lateral wall of the body of the ventricle. And there was the septum, and inferior to the septum, this is fornix, forming or sitting in the midline, the third ventricle structures. So this is the same body of the, will be turning around the thalamus and will be going to the temporal horn, which will be coming later. But let me first remove all of the caudate nucleus to expose the internal capsule fibers. As in some talks, you will be listening, actually, the caudate nucleus and the lentiform nucleus is not connected only, let me go back, as here, inferiorly, they are also connected these through cortical structures going in between the internal capsule fibers. So now we are looking above to ventricles, to lateral ventricular system. This is the left side. This is the left side. This is the right side. This is choroid plexus. This is the fornix. There was a septum, which we don't see here. This is the left fornix. This is the right fornix. Is partially removed to expose the internal capsule, which is located at the roof of the third ventricle. So normally, when we go into the ventricle, we see the structures as the left side, because the fornix is here. This is the body of the fornix. The choroid plexus goes to the foramen of Monro. So lateral to the choroid plexus, the structure located at the bottom of the lateral ventricle is the thalamus, and the structure forming the lateral wall of the lateral ventricle is the body of the caudate nucleus. This is the head of the caudate nucleus. This is the body of the caudate nucleus. And at the more posteriorly, at the posterior border of the lateral ventricle, the caudate nucleus will begin to turn around the ventricular system to the temporal horn. Let's see the right side. Again, this is the foramen of Monro. The fornix is partially removed to expose all the thalamus here, forming the roof, the bottom of the lateral ventricle, and laterally, this is the body of the caudate nucleus, which will be later becoming the tail of the caudate nucleus. Let me just say, I will be later than showing, but here you see some lining here, which is in between the thalamus and the caudate nucleus. There will be going the stria terminalis, going to the amygdala in the temporal horn. So let's then see a little bit more posteriorly. This is the thalamus here, and this is all the way the body of the caudate nucleus, which begins to be the tail of the caudate nucleus, and then there will be it will be turning to the temporal horn, just like the fornix going over the hippocampus, which is not here. So this is the thalamus forming the bottom of the lateral ventricle and also the anterior wall of the atrium of the lateral ventricle. And this is the internal capsule here. Let's see these structures, particularly the tail of the caudate nucleus. This is the inferior surface of the temporal horn, the parahippocampal gyrus, and the fusiform gyri are removed. Here on this side, here we see the hippocampus. This is the choroid plexus. When we remove the body and the head of the hippocampus, then we begin to see the uncus here and the posterior segment of the uncus. This is the apex of the uncus, and the posterior segment of the uncus is hosted by the amygdala, and amygdala is connected with the head of the caudate nucleus through the stria terminalis, and this gray matter structure here going also to the amygdala is the tail of the caudate nucleus. When we remove those, we see here the amygdala located in the posterior segment of the uncus. Here there was the optic tract, I'm sorry, and when we remove it, partially we also see the ventral amygdalofugal pathway, which is the connection of the amygdala with the basal ganglia. And also, let me express, this is the mesencephalon, as you see, and this is the most inferior basal ganglia located in the mesencephalus, which is the substantia nigra, which we'll be seeing here a little bit more. And just superior to it, to substantia nigra, most inferior part, subthalamic nucleus, will be present, but it is not dissected here. Thank you very much.
Thank you very much, Dr. Barış.
Thank you, Barış. I think you presented the best dissection of the basal ganglia. I think at the end of the session, we will have questions and comments, and we can continue with the ABIDA. Then at the end of the session, we can take questions. If you have time, Barış. If you don't have time, we can take questions for now.
I'm glad to be here. I'm here. I have
Okay.
time.